Okay, Conscious back here, and today we are going to be working on state machines, or implementing a state machine for our project. We covered some previous, or in our previous tutorials, we covered some animations, run, jump, idle. But as we keep adding more and more animations, it's going to become very hard to update and upkeep this. It's going to get to be very confusing. So today we're going to do a little bit of refactoring of our code, and it's going to keep it more organized and really easier to expand. So every time we want to make a new animation, it's going to be a lot easier to plug it in. So before we actually dive into doing the refactoring, just wanted to give a little bit of context on state machines. It's a programming pattern that's going to help us manage different states for our character to be in. And there's a couple of, rules, I guess you could say, around these state machines where only one state can be active at a time. So we can only be in idle or running or jumping. We can't have all three at the same time or more than one. Each state's going to handle its own logic, which is going to help us decouple it from here inside of our player script. And then we're going to have our states transition to other states based on specific conditions. For example, if you press the D key or the arrow right key, it's going to start running. Okay, so now that we have a little bit of the background covered, let's dive into actually starting our implementation of the base state class. So where I'm going to put this is, you can put this wherever. I'm going to put it inside of my player. I'm going to create a new folder and call it state. Call it state. Inside of there, I'm going to create a script. I'm just going to call it state. And we're going to give it a class name for our base class. It's just going to be called state, and we're good for it to just extend nodes, or extend from the node. And this is going to be our base state class, where all of our other states that we create are going to inherit from. So I'm going to actually get rid of all of this. And we're going to need two variables, and they're going to be slightly different than variables that we've used in the past. It's going to be, we're going to use two static variables, one for our player, and you can't type today, and static var for our state machine, which we haven't implemented. We're going to do that afterwards, so this will likely continue to error out. So for now, let's just comment it out. And actually, I don't want to comment it out because we're going to need the reference to it. Just so we can get rid of this error, I'm going to also create another script. Just do this, just call it state machine. Open this up, class name, state machine. Now that we'll get rid of some of the errors, at least for now. And the thing you know about static variables are that it's going to be shared across all states. So this means that every state will have access to the same player and same state machine, which is important. We are only going to have one player and one state machine, so this just enables us to access that across all of our states. Now we're going to have a few base methods that all of our states are going to need to override down the road. So the first one is going to be our enter function. So this is going to be what happens when we enter the state. Okay, so we're going to use this to set up our initial conditions, animations, resetting some values. And a lot of this, all of these will make a little bit more sense once we actually go into and start implementing our individual states. But I'm going to leave some of these comments here so that we have some context in our base class as to what we're expecting each of these methods to do. Then we're also going to have, if we can enter, we're also going to need to exit. All right, and this is going to be called whenever we're leaving this state. If we need to do any cleanup, resetting of values, or stopping an effect or a timer, this is where we're going to do that. The next one is going to be called process, not to be confused with the underscore process that is the built-in Godot, but this is going to be where we're calling it This is called every frame during the process method. And this will come together as we build out our state machine. So any non-physics updates, animation changes, anything like that, that's what we're going to call here. And where this is going to differ from the enter exit method is this is actually going to return a state. So it's going to give us the next state to change into, or we're going to return null if we're going to stay in the same state. The next one is going to be func physics process. Very similar to what, again, not the underscore one. This is going to be called every physics frame during physics process. So you can kind of see the pattern that we're going for now. This is also going to return a state. And then the last one that we're going to have is func, no, sorry, not the unhandled input. This is also going to return a state, but we're going to get an event here. So it's going to be, if they're pressing the space bar, we need to handle that input. It's going to be, an input event. This is also going to return a state. So we return null if we're just going to stay in the current state. So this is our base implementation of the state. Called when input events occur. Just wanted to add that last comment. Now we can move on to the actual state machine. So we can go into here. We're going to get rid of these comments right off the bat. And the state machine is going to be the class that manages all of our states and their transitions. So in order to do that, we need to be able to access all of our states. So we're going to have a variable of states, which is an array of state. And we're going to default that to an empty array. Then we need to get a reference to our current state, which again is a state. We don't need any assignment there. Then variable, we're going to get our previous state, which is also a state. This is going to be helpful for returning to previous states and things like that. So now we have inside of our ready function, which is going to be called when we initialize this state machine. We want to update our process mode. And I will explain this in a second, but it's going to be node process mode disabled. So we're going to start this process mode as disabled, which prevents errors if states try to access the player before our actual setup of this state machine. So now we have that. We have our process here, which is called every frame, and it is going to be change state, our current state dot process delta. So this is going to be if we are calling a new state, we're going to change the state. Otherwise, we're returning null. Nothing's happening. We're staying in our current state. The next one is our physics process. We're going to do the same thing here. Change state, current state dot physics. We're just calling it dot physics delta. And then this is going, again, if this physics method, which we have inside of our state, returns a state, it's going to change the state for us. Need to add that tab here. And before we actually get into the rest of them, I want to build out the change state method so you can see what that is, and also we'll get rid of some of these errors. So we're going to do func change state. We're going to take in a new state because we need something to change into. We need to, from our previous state into a new state, which is going to be of type state. It's going to return nothing. So if we don't get a state, if not, we're going to do if new state equals null, or new state is the current state, we're not doing anything, so we're just going to return. If we have a current state, we're going to run that state's exit method, so we can do all the cleanup out of that state that we need to. Then we're going to store our previous state as the current state, so we have a reference to the previous state. Then we are going to call the current state, make it our new state, and then we're going to call the enter method of our new state. So this is what this is going to be doing. Now that we have this, it's going can kind of more easily navigate with our type hints and everything like that. But let's keep filling the rest of this out now. So after the physics process, why is this giving me an error? Too many arguments. Expected at most 0, but received 1. So in my process, I'm not giving it delta. I don't think we're doing that in the physics either. Just make sure. Yeah, we're not doing that in physics. Oh, but I'm actually incorrect. We should be adding that. So apologies. This should be taking in a delta of float. And this should also be taking in delta. So now that should clear those errors up. Sorry about that. Now we need to do the unhandled input, which takes in the input event. So then we're going to do change state. So you can see this starting to get a little repetitive. We're going to call unhandled input, and then we pass in the event. Cool. So now we have all these methods that can handle, and our state machine is going to be using these to process our state changes. But we need to actually configure our state machine. So I'm going to call this configure. We're passing in the player. We're going to need the instance of the player. We're not going to return anything though. So the first thing we have to do is get all of the child nodes that are states. So in order to visualize this a little bit more, let's go to our player, and we're going to add a child node of just a regular node. I'm going to rename this, call it a state machine. We can attach our script to the state machine, and we are going to add another child node of just node. We're going to call this idle state, and we're going to drag the state script. Oh, sorry, no, we're not going to drag the state script there. Going to attach a script called idle state, and what this is going to do, we're going to give it a class name, and we're going to extend from state. So this gives us all access. This gives us access to everything in the state class. What we're going to want to do is copy everything but the variables and state name, go to our idle state, and we're going to have to override all of these methods, which we will come back to. But now this will make a little bit more sense, where we need to get all the child nodes that are states within our state machine. So we can get for child in get children. So this on our state machine is going to loop through everything, all of its children under this node. And then if child is state, so if it is a state, we're going to get our states array and append that child to the array. So now we're actually, instead of having an empty array, we will hopefully have states. But if we don't, if states is empty, we return. It means we don't have states, so we don't want to continue. Now we need to actually set up the static variables that we mentioned inside of the state. So what we can do is grab the first state, which would be states at index 0, and then the player is going to equal our player, which is right here. Then states dot state machine is going to equal self, not elf, this is self. because we are a state machine here, so we're going to pass in our self to there. Okay. Then we are going to go into our, we actually have to enter a state, right? So we are going to change state, and we are going to do that in the states.0. And this is generally, for our purposes, going to always be idle. I tend to make idle state as my first state. It's usually the simplest, and it's usually what every character is going to enter prior to doing anything else. They're going to be idle. And then after we've done that, we can revisit the process mode, and we can set that back to inherit. Okay, so this is the setup of our state machine class. I know it looks a little daunting, but once we start implementing it into the idle state, I think it'll be a lot more clear as to why it's beneficial. We have to go back to our player. Let's go back to our player scene, right? So here, we are going to need to do a little bit of setup inside of our player in order to actually use the state machine properly. So we're going to have to get a reference to our state machine as an onReady variable. And then inside of our ready function, which we don't currently have, so we're going to make a ready function. So anytime we're initiating our player, we want to do state machine configure, which is what we just made. And then we're passing in our self because we are of type player. And that's all we have to do. It's the only updates that we need right now. We're going to come back to this after we start implementing some of our states, but this is all that we have to do inside of our player right now to configure the state machine properly. So now we're going to just go back and do our basic idle state. Okay. So what happens here when we enter? We're going to access our player, which we have in the state class, and then we have access to everything inside of our player instance, which is going to be velocity.x. It's going to be 0. When we enter the idle state, we're not moving. And then we're also going to access our animation player and play idle. So in our process method, we are going to have a couple set up. This is also not physics process. Sorry, guys. Going through, we're just going to call this physics, which is what we were referencing here. Perfect. Okay. So what we're going to do in process, actually, let's demo this first. So player, we're going to not handle ground movement here. So since we're not doing anything on the ground, which means we're not changing the velocity here, anything like that. If we play this, we're still configured. I can't do anything though. I'm pressing buttons. You can probably hear my keyboard. We can't do anything even though we've configured our state machine, and that's because we've only configured it to enter the idle state. We haven't configured anything to transition into other states. So in order for us to do that, we're going to make a couple other just base nodes for us. I'm going to make 3 more nodes. We're going to have run state, jump state, and fall state. We need to make sure that we attach the state script. Again, sorry, no we don't. Getting tripped up here. We are going to attach run state scripts to the run state. We're going to attach a jump state script to that, and we're going to attach a fall state script to the fall state. I'm just going to do a little bit of reorganization here. Put these in the state folder. Okay. And now we're going to do some basic class naming, so we have better references to these. We're in the run state, and it extends state. I'm actually going to go back to the idle state, copy all of this, just so I can put this inside I am going to replace this though and make it pass. Okay, now we can set up our false state. I'm going to do this, pass, class name, false state. This extends state. So we have our idle state, false state. We need class name of jump state, which extends state. Run state, jump state, idle state, false state, run state. Okay, so we have all of our basic states set up. We're going to go back to our idle state now. And we're going to get references to all three of these states, because from the idle state, probably won't hit the false state, just in case. But we are going to hit the run state and the jump state, right? Let's handle the jump state first. So that's going to be in our input. So if events, we're actually using this, you have the underscore prior to your variables inside of methods if you're not going to use them. So since we're going to use them, I'm just going to get rid of that underscore. And if the event is action pressed jump and player dot is on floor, we return the jump state. And we can go back to our player script, and we're going to get rid of handle jump. And we're just going to comment it out for right now, actually. Okay. And what we're going to do to prove that we're going to enter the jump state, we can go to enter. I'm going to print jump state entered. Okay. So now if we hit play, and I'm hitting spacebar, you can see I entered the jump state. Again, we can't do anything because we haven't done any of the transitions in the jump state. So it's not going to do anything. It doesn't know where to go after it's entered the jump state. So let's finish out our idle state though. So in the process, or in the physics, apologies, we're going to do if not player is on the floor, return the false state. Otherwise, we're the same. Staying in idle. And then if player dot direction doesn't equal 0, which means we're pressing the left or right keys, we return the run state. So now that our idle state is fully configured, we need to set up the rest of the states. So let's just work our way down this list. Let's go to the run state. Okay, so just like before, I'm going to get the other three states and make them on-ready variables inside of our script. We are going to want references to all of these at some point in here. So we're going to need those. Again, in the enter, we want to start playing our animation. When we enter the run animation, we need to get to our player, animation player, and play, run. Easy. And inside of our physics, actually let's cover the let's cover process first. So if player dot direction equals 0, so if we stop moving, we're going to return to our idle state. So that's all we're going to be doing in the process. In our physics, this is where we're going to be applying some of this ground movement stuff that we were doing before. So we're going to do player dot velocity dot x equals player dot direction times player dot speed. Okay, great. We are going to handle this somewhere else. I don't want to handle it inside of each individual state. I think there's going to be an easier way for us to do it, possibly up in the process, but we'll do that once we wrap up the states. So go back to our run state. If we're not on the floor, that means we're in our fall state. We're falling. And in our input, I am going to take exactly what's in idle and pop it in the run state. And then that covers our run state. So we should be able to successfully, all right, sorry, I have to make one more change. I left this underscore here, so I get rid of that. I should get rid of my error. Okay, so after debugging a little bit, sorry about that, guys, I figured out what was going on. And so what's actually happening is we're entering the fall state immediately because our player in our test scene is not on the floor right away, and I never configured the fall state yet. So all we have to do is, if player is on the floor, return our idle state. Now that will allow us to go back and, all right, I still forgot to do something. What did I forget? Yikes, I just didn't put the return. Okay, let me get rid of my print statements here. I think they're in the state machine, yeah. Okay, so now if I hit play, we're good. I can actually run, but you can see we still have the issues of flipping sprite, and we're just infinitely running out because we haven't completely done the run state. So let's wrap these up. Okay, so in the run state, need to add a couple of things. We need to return to our idle state properly, right? Again, I forgot my return here, so that's going to be why we are continuously running. There we go. Okay. Silly mistakes, guys. It happens. It happens all the time. You know, it's part of the process. Okay, so now you can see there is still an issue, right? Our sprite is flipping, but then it just yoinks right back to here. Okay, so now I see what the issue is here. It's with sprite flip H. We only want to be flipping if the direction's not 0, because whenever we release a key, direction goes immediately back to 0. So we don't want to change it if we go back to 0. So if direction sprite flip. So if there's a value non-zero, there we go. Okay, perfect. So now we have that handled. Now we need to go into our run state because we don't have everything set up here. Yes, we do. Okay, so the last thing we actually need is our jump state. So let's work on that. In our enter, we're not going to do, I'm not going to print anything anymore. We're going to do player.animationPlayer.play jump, just as we've been doing with the rest of them. We need to do a little bit more here though, because we need to also apply our jump force as soon as we enter. So we're going to do player.velocity.y equals player.jump force. Great. We are not going to be doing anything in our process method, but we are going to be doing stuff in our physics. So if there's a player.direction, player.velocity.x, I'm actually going to go back to our player script, and we should be able to, we don't need this anymore. Or we shouldn't. We're going to handle our air movement. And we're going to go back to our jump. Just do this. Get rid of that. Okay. Velocity, right. So since we're not in the player right now, we need to add player dot in front of all of these variables that we're trying to access from the player. Great. need to also enter our fall state, right? So after we hit the peak of our jump, we want to go into the fall state. So if player dot velocity dot y is greater than or equal to 0, return our fall state, which we need to pull in here as an onReady. And when we're in the air, we're never going to be able to hit the run or idle state, so we're not even going to handle those right now. We're not going to do any unhandled input. If we ever had a double jump, we want to handle that in here. But for right now, we don't. We should spell velocity correctly as well. So here, now we should be able to jump. All right, we didn't hit our fall state. So something is incorrect here. It's not incorrect. I didn't configure it. So player.animation, player.play, fall. And then when we're on the floor, we're going to go into our idle state. But we have a little bit more here. When we're on the floor, we don't necessarily just only want to go into the idle state. We want to see if there's no player direction. So if they're not using the arrow keys, then we're going to idle state. Else, we're going to return the run state. That means they're just sprinting forward, okay? There you go. All right, that's working as intended, but we still have to do a little bit more to the physics. So we need to handle a little bit more of the gravity and the deceleration that we've applied in the jump state as well. So I'm going to copy this. It should be the same code. Go to our fall state. Great. Okay, let's play. And now we can do everything in every state that we want. Okay, so the last thing I want to do is clean up our player script. So we should have everything in our state machine handled. So we don't need any of this code anymore. So let's get rid of all of this. The only thing that we're going to keep is the gravity in this. We have a very, very simplified player script right now. Just confirm, let's play it. Everything is looking good. And on that note, I think this about wraps up the state machine video. Thanks for sticking around on this one. I know it was a long one. I'll try and make the next one a little bit shorter, but please like and subscribe to see when the next video comes out. Have a good one.